So I got to do the opportunity to do some research over this summer, and to do it, I need to learn this programming language called lean4, and it's like a math proof language, and that's all I know about it. I unfortunately have to use Visual Studio Code. I don't feel like building the entire code base. So I'm just going to use Visual Studio and then try to learn this. I'm genuinely no clue what I'm getting into. But let's see. Blah, blah. Okay. It is best if you read this book with the lean open in your... Okay, yeah. The most important thing to understand... Okay, programs are first and foremost expressions, and the primary way to think about computation is in evaluating expression to find their value. Once given a value, variables cannot be reassigned. Evaluating an expression cannot have side effects. Have the same value, then replacing will not cause... Okay. Okay. So how do I do this? So eval. So can I run? Okay. Do I delete this? I'm gonna delete that. Right. And then eval 1 plus 2. That works? Why is there blue? Fine. Okay, and it's based on where I'm clicking. That's strange. Look, if I click here, then eval 3. 2. Can I do 5 times 2? Yep, I can do 10. 1 minus 3. Whoa, okay. I guess there's no negatives. Okay, there's negatives. I'm guessing there's no, what? That's strange. Okay. There's negative values. Okay. But subtraction just isn't real. Okay, we just only use addition. And is that the same with division? 6 divided by 3, 2. 3 divided by 6, that's a decimal. 2 have to do 3 point, like this. Yes, okay. So then the types are important. Okay, and then present. Okay. So this should be 1 plus 2 times 5. 2 times 5, 10 plus 1, 11. Okay, that's correct. So a function next to its argument, f and then x. Functions, application. Okay, so we don't really care about the parentheses here. So we could evaluate this expression string dot append hello and then lean. Cool. Just as an order of operations will depend on the parentheses and expression. So 1 plus 2, 3, 3, 5, 15. Parentheses are also necessary when a function's another function call. Okay. String append, great. Oh, so then it'll be string oak tree, great. I'm guessing. So if I do string dot append great, right? What's wrong with this? Why does it need 2? Fine. I'll do great anyways. Then I'm gonna do string the append oak tree. Oh, great oak tree. Okay. Fine. If then else. Okay, I didn't read any of this, I'll be honest. Fine. Let me reduce this size. Right. So I could say string the append. There's no eval here. Okay, yeah, I'm pretty sure eval should be there. Yeah, there's no that error. We're gonna evaluate string append. It is 2. If 1 is greater than 2, then yes. Else, say no, and it should. It is not. Okay. It is no. 1 is not greater than 2, so then it's no, so it is no. Fine. Oh, I have some homework assignments. 19. Can I do eval string dot or append? I'm gonna append that with. So okay, I think I'm starting to get this append command. So for some reason, I thought it was appending any value to like the view, right? No, we're just combining two strings and it will print that combination. So it's not like a print. All right, so now I'm appending this one and that one, and I think what confused me is because it doesn't have parentheses that a normal language would have. Oh my god, like this, and it. What the heck is going on? It would be something like that. That's how that would make more sense to me, but they said it's like a waste of space having those parentheses, so it's fine. And then we can do string.append. B. And then we could do, oh, is that Gemini? I have Gemini on here. Can I turn this off? Oh my god. It's so annoying. Okay, while we're at it, let's get rid of this. Leave me alone. Okay. A, B, C. Okay, that's fine. Okay, this makes sense. So now this A is one string, and that string is getting appended to this string. So then here, this will be treated as one string, and then this string is going to be made of BC. So then we're combining A and BC. Okay, cool. What else do we got? String.append. Okay. So now we're just doing it backwards. Cool. Now we're gonna do C. Fantastic. We also have eval our booleans. If 3 is equal to 3, then 5 else 7. So if 3 is equal to 3, then 5. Okay, yeah, we know that's true. Eval if 3 is equal to 4, then equal, then string equal, else not equal. Cool. Okay, let me restart Visual Studios. I don't have that crap on my screen. Fantastic. And what this language does is that every time we click here, it scrolls. So okay, types. I think I got a basic idea of some types. Okay, I'll just ignore that. Okay, let's read it. Program communicate. Okay, okay, fine. Every program in Lean must have a type. In particular, every expression must have a type before it can be evaluated. In the example so far, Lean has been able to discover a type on its own, but it's sometimes necessary to provide one. This is done using a colon operator inside parentheses. Cool. So let's delete that crap. So realistically, we have 1 plus 2, and those are natural numbers. Is that why it's strange when I was doing like 1 minus 2, it's natural numbers. If I change this into an int, then that's fine. Okay, so I was pretty much trying to fight against the interpreter. Here I could just define the type, which makes more sense. Oh wow, there's no largest numbers. Okay, so if I don't want to evaluate it, I just want to check. And so all these commands are lowercase, but strangely enough, types are capitalized. So then I can do 1 minus 2. And right now, it's treating this as a natural number, and that's what was the problem I was going through earlier. But if I define it as an int, then all of a sudden, we could look. If I evaluate it without defining it, that's 0. If I define it as int, then now, okay, I gotcha. So now it's an int. Reserve. Okay, there, no doubles. Fine. Okay, functions. Okay, this is the juice. Definitions are introduced using the def keyword for instance to define a name hello, to refer to the string hello, right? Okay. So def, our function hello, is defined as, oh, that's a cool, that's cool. Hello. It says it's already been declared. So then like do it's already been defined. That doesn't make sense. Hey buddy. Doesn't make sense. Where did I define hello? Okay, fine. Did it tell me where? Okay. Okay, so it's just like Python here. So like if I want to define def lean, and I can say it's a string. A lean is gonna be type string defined as a lean, right? And then I could do eval string dot append hello, and then string dot append space lean, which is such a weird way to do something, but I think because it's not a normal language, printing is not something you normally do. I think the easiest way to like type things would be then, hi, my name is, and I could say, and then I could type in lean. No. Oh. Yeah. Cool. I guess that makes sense. So we have def add 1 and nat. So we're going to add a natural number. We're going to input a natural number. What? Okay. Okay. What? I'm so confused. So right here, our function definition, add 1, will take the input, okay, take the argument, and is this the return? Is return this? Okay. So this will be the return, right? And this string is the return. So this one will be the return. And this is just an argument, and the arguments are in the parentheses. So, yes, okay. And then we could see that here. There's 2 arguments. Every individual argument is in the parentheses. So you're going to do add 1 nat, and that's going to... Okay, let's retype this line. So def add 1 n, we're going to have an argument of a natural number, and that natural number, that will return a natural number, and that's defined as n plus 1, right? So then I could do eval add 1 to 6, 4, 5, and that's just, right? And then I could also do a check, and that'll be a natural number. What if I say instead of nat, I have an int? Then I could check, it returns an int. Yeah, so fine. Okay, we can. This one shows us how to find the maximum. Def maximum n. So our n input as defined. That's with type natural, and then we also have another input that's also type natural, and our return will be nat, and that function is defined as, and then we could do multiple lines. Cool. I don't think the tabs matter, but so then this is what we learned earlier. So if our n argument is less than k, then we return k. So there's no return keyword. Oh, it's not a return. It's based on okay. The multiple lines is messing with my head. Right. This is the same thing as just this. Right. Well, it looks all cute now. Right. That's the same thing as what we did earlier. If 3 is equal to 3, then hi, else by, right? Right, that's high. 4, and it should be by, right? Same thing, same idea, but this gets us the max. I don't like how it's called max. We just found the max. So we could do then eval maximum. Oh gosh, 4, 5. And max here. 1,000 bigger than 3,000. Will be bigger than that. Yeah, cool. Similarly, the function space between joins 2 strings. Oh, wow. So then we can make it easier to actually print some words. Space between before. Return string. And then that is defined as, oh, yeah, after, right? Cool. Now I could say do space, we could do eval space between hello, and then world a. Oh, yes, that's really cool. So then with maximum eval, we could do maximum 3 plus 8, and our second input could be 2 times 3. 3 plus 8 would be bigger than. Yes, okay. So we can have everything in functions. That's really cool. I mean, a function, parentheses, and it will respect that. Yeah. Ooh. str. Okay, so we can make a definition. So then we could use that as a type. Fine. Structure. Okay. So we can make structures like C. Okay, we got floats. Accidentally cut myself. Unfortunate. Okay. So yes, floats. Fine. Okay, so then we can make points using a structure. Okay. I like that. So then we could do structure point where x is a float and y is also a float. Okay, so let me increase this. Okay. After this declaration, point is a new structure type. Typical way to create a value of a structure type is to provide values for all of its fields inside curly braces. The origin of a Cartesian plane is where x and y are both 0. So we could do def origin to define the origin, which is the type point is defined as x, and where that point where x is defined as 0 and y is defined as 0. Fantastic. So then if we do eval at origin, okay, we'll get our 0, 0. Beautiful. I don't know why eval is blue. I don't care, because structures exist to bundle up collection of data. Naming it and treating it as a single unit is important. Max, quiet. Fine. Okay, here we go. So, okay. So then we can do eval origin.x. Fantastic. We can also do, makes sense where we can do eval origin.y. Also 0. What if I change this here? Oh, yeah. Okay. Origin. Cool. Origin is actually at 0, 0, so we'll leave it like that. For instance, addition of points can be performed by adding the underlying coordinates add points. Okay. And then they'll define it here, which that makes sense. I don't think I need to retype that. It's pretty simple. Yeah, plug in 2 points and we get the x's. Oh yeah, but here we could see where this is super important that we keep it within the same type of structure. It's just they just defined it as a new point. Ah, okay, cool. In the distance, we can use those. Cool. And that's just defined as a value. Okay, distance. Cool. We do 3D points. Hey, fresh point. Okay, I don't need to know about it behind the scenes. Should I do this exercise? Maybe I'll find the behind the scenes stuff that I should probably know. Okay. Define a structure named rectangular prism. Okay, I'm gonna actually comment these out so I have some reference. So define a structure named rectangular prism that contains where we have height, which has a float. What else? Width is also a float, and depth is also a float. Oh my goodness, that is a big F. What? Okay. What are we doing? Cool. Define function named volume. Okay. So functions are lowercase. Structures are capitalized. Volume of type rectangular sum, and where we return wait, what? Is it taking input? I'm confused. Okay. Define a function named volume, rectangular prism, that outputs a float. So, like, that notation makes no sense. Is there something? It doesn't mean, like, is it like A? Something like that? I'm so lost. What is it talking about? Define a function Name the volume. Okay, let's look at distance. This is why I should have done it for real. Yeah, okay. Put in prism. All right. Okay, I think that's probably the best way to do it. And then the volume of prism is length times width times height. So we could just say let's get this notation is equal float. Oh, what the heck? I didn't know that. So it's just gonna be float, and all we need to do is do prism dot length height times prism dot depth times prism dot width. There you go. I think that's it. All right, and then if I do a 3 by 3 by 3, then let's say we're gonna def cube, which is just a prism, and we could say, how do we define it? How do we define origin? Oh. Okay, so this is tedious. Right, that's our cube, and then if we do eval volume cube, there you go. I did it. Cool. Define a structure named segment that represents a line segment by its endpoints. Compute the length of a line. Okay, next. Structure segment where okay, so we give it 2 points. So we could just say P1 point, P2 point, since we already have this defined. What? Why are we doing this? What is this? Why is this here? Segment. Oh. Okay. P1. There we go. I have my point. And then the length of the line segment would just be represented by the distance. So I will end up coding this distance in. I guess the absolute value of the distance. Where's distance? Don't want to really think about it. Def dist. Okay, wait. Let's go here. Def distance p1 point 2 point float is defined as float.squirt p2.x minus p1.x square root 2 squared plus p2.y minus p1.y There we go. That's our distance. So then the length of the segment is really just, what is this question asking again? The length of a line. There we go. And I guess yeah, square root can never be negative, so I guess I don't need to get any absolute value. Okay, then we can do def seg length. Yeah, I think they use camel case. Then we plug in a mint, and that is defined as distance point 1 and then 0.2. Ah! What am I doing? That is defined. This should be actually just a float. And this will be, let's say, segment, type segment. Okay, just convert those to lowercase. Alright, and then we could eval seg length to define the cube at. I think we could do something like this. This is weird. So now it's just 2 points. I could do a point. Oh my god. Okay. So we have point X. Does that work? let's just do a check. Let's go full screen with this. Point. Or do I have to do something like that? Do I have to define it? I really don't feel like defining it. Oh! Okay, so then I could do... There you go. And that will be point. That's how you solo define it. So then I could do... So I could do eval seg length, all within here. It's gonna be low key gross, but that's okay. We need 2 segments. Right. So I can have a segment here and a segment there. And this segment consists of 2 points. Right. So this segment, and we could acknowledge that as a segment. Okay. In this segment, P1, we can have P1, and then something like that. Then we can say X is defined as, we can say 0, and then Y is defined as 1. And then we can come point, right? And then we can clean that. Okay, look. So this one holds the first segment. Because, no, this should be fine, no? So if I do a check, that's point, right? Now if I do point here, in a point, comma. Okay, so we do a check, point, right? So this is 1 point. Oh! P1 is defined as. P2 is defined as. Oh! Okay. So then I could delete that, right? And it's this instead of this nasty thing here, and put that, and then put that there. I don't know why there's 2. Oh, I did it. Okay. This is horrid, but I could change these individual points. Oh my goodness. So this is the length of my segment. That is the most disgusting thing ever. Fine. I think I understand it. Yeah, I'm not even trying that. Data type and patterns. Pattern matching. Okay. Oh, I was about to quit, but I'm almost done with getting to know lean. Recursive functions. We got classes. Fine. Okay. Polymorphism. Can I do something actually cool then? Yeah, I'm getting bored of this. Okay. Types, monads, okay. Some basic lean4 proofs. Theorem, 1 + 1. Okay, there's a lot. Classical logic. Okay. So now this notation isn't like destroying my brain no more. Learn lean4. Okay, I'm fine with that now. Data modeling. Would I have to go through this whole book? I don't got the time for that. Let me just see some people's proofs. Wow. That's really cool. This is real cool stuff here. I want to use it for finance. Financial proofs using lean. Okay, I guess I have to work through this. Pillars. Pillar B, tactics, introduction. What is a proof? Okay, so if we have divide x, y, oh, they don't. Oh, these are both natural numbers. That's cool. So safe divide. X, Y, both natural numbers, where H, what was H? H is where Y cannot equal 0. And then all this returns a natural number xy. To call this, you must prove, oh my gosh, that y does not equal to 0. (10 divided by 2, or y). So then we prove that 2 isn't equal to, okay. I call it to provide proof. Y is not 0. No proof, no function call it. Wow, that's a strong guarantee. So, theorem, example proof. For all natural numbers n plus 0 is equal to n. It's defined by, and then this is our theorem. Intro n wow. Okay. Now, I think this is where the real magic happens. Well, we'll do that some other time. But this is really cool. I'm gotta look more into this.